All right, guys, here's a video on absolute value functions. So let's just get started. Okay, an absolute value function, we know the parent function, we talked about this, but that's f of x equals absolute value of x. Remember, absolute value functions look like a V. So we're going to graph those. Basically, absolute value functions are a piecewise function where we have half of it is this line and half of it is that line. Okay, so this is the easy way. If you cannot remember all the other rules and things, graphing it by a table is the easiest way. So let's just get into it. So we're going to complete the table to graph the function. So here's the absolute value function right here. And we're just going to plug these numbers into it and see what we get out. So when we plug -3 into this, we have f of x equals absolute value of -3. Well, that equals 3. Absolute value of -2 is 2. Absolute value of -1 is 1. Absolute value of 0 is 0. The absolute value of 1 is 1, 2, and 3. All right, and then this is literally just graphing from a table. It's stuff we've been doing forever. So we graph, let's start with 0, 0. Graph that point. Then graph this point, -1, 1. And graph this point, 1, 1. Then graph -2, 2. And graph this point, 2, 2. Remember, this is our x value, this is our y value. That should go right here, 2, 2, 3, 3, 3, 3, and so on. And so you can graph this. That is our absolute value function. That's our main function. Remember, it looks like a V, and the turning point of it is called the vertex. Let's take a look at the domain and range for this. So if I take my pen and I put it on this graph somewhere, if I'm way over here, am I going to touch a point on my graph? Well, yeah, because this line goes on forever and ever and ever in that direction. So forever and ever in that direction, there's going to be a point on my graph, and all the way through here, all the way here, forever and ever in this way. So the domain of this one is all real numbers, and you'll find for most of our absolute value functions, the ones we're going to talk about right now, that either point up or point down, that it's always going to be all real numbers, because these ones are always going out forever and ever in the x and negative x and positive x. All right, what about our range though? So if I take my pen again, if I'm down here, am I touching a point on my graph? Nope, I'm not. So when I start to touch my graph was right here at 0, 0. So for any values that are less than 0 for the y, there's no value less than 0. On this graph. There's not a single point on this graph that has a value less than 0 for its y value. All of the y values are greater than 0 or equal to 0. So for our range, we have y is greater than or equal to 0. All right, so here's our steps to graphing our absolute value functions. The first step, super important step, you find the x value of the vertex. And you do that by setting whatever's inside of the absolute values equal to 0 and solving for x. That's going to give us the x value of our vertex. Then we place that in the middle of our row and we solve for y. So when we plug in our x value of our vertex, figure out what the y value has to be, and then we graph. So let's just jump right in. Okay, so step number 1 is we set what's inside of the absolute values equal to 0. So we say x minus 4 equals 0. We just take whatever's inside of it, not the absolute value bars, nothing else. We just take whatever's inside of it and we set it equal to 0 and we solve for x. So we add 4 to both sides. We get x equals 4. That's the x coordinate of our vertex. Now remember, a function is just like a machine. You plug something in, we put in our x, and we get out a y. So when I put in this x, what y do I get out? Okay, so let's put that value right here on our table. So when I plug this into my function machine, when I take the 4 and put it back in here, what do I get out for my y? Well, I get 4 minus 4 gives me 0. The absolute value of 0 is still 0. So when I plug in 4 for x, I get 0 for y. So that is my vertex. 4, 0. So then I can graph that here. 1, 2, 3, 4, 0. That's my vertex. That's my turning point, right? So then what you do is you pick numbers that are smaller than 4 and bigger than 4, and you figure out what our function is at those values as well. So again, this is just a machine. We plug a function in, or we plug a number in, the function machine spits out another number. So when we plug 3 into here, we get 3 minus 1, or minus 4, excuse me, 3 minus 4 gives us -1. The absolute value of -1 is +1. Plug in 2. 2 minus 4 gives us -2. Well, the absolute value of -2 is 2. 1 minus 4 gives us the absolute value of -3, which is 3. And I can tell you that these are going to reflect that. We could plug those in. 5 minus 4 is 1. 6 minus 4 is 2. 7 minus 4 is 3. But because this is really reflected on its line of symmetry right here in the vertex, it doesn't really matter. You can find half of the points, and then you should, if you're making the same size steps, you should find all the other points. Okay, so let's just plot these points. When x is equal to 3, y is equal to 1. When x is equal to 2, y is equal to 2. And when x is equal to 1, y is equal to 3. When x is equal to 5, y is equal to 1. When x is equal to 2, y is equal to 6. Or x is equal to 6, y is equal to 2, excuse me. And when x is equal to 7, y is equal to 3. So we just connect our points. Remember, this is just graphing from a table. You just plug in points, and then you connect them when you're all done. All right, so what's our domain and range of this one? Well, remember, our domain for all of these that we're working with right now are all real numbers, because these go forever and ever in this direction and forever and ever in this direction. Okay, now our range, again, what is the lowest y value that we can take? There's not a single point on my graph that has this y value. There's not a single point that has a y that is less than 0. But when I get to 0 and I come up here, now I have points on my graph that have those as a value, right? There's points here that have 0 as their y value. There's points here that have larger numbers as their y value. And if I go forever to infinity, I'm always going to have a point on my graph that has that y value, no matter what number I pick. So it starts at 0 and goes up. So that means I'm going to say y is greater than or equal to 0. All right, let's take a look at this one. Okay, first step is we set our vertex, or we set what's inside the absolute value equal to 0 to get our vertex. So we put 2x plus 6 equals 0. So we solve this, whatever's inside of our absolute values, we solve that for x. So we subtract 6, and we have 2x equals -6 divided by 2. So x equals -3. That's the x coordinate of our vertex. Now we just have to find the y coordinate, so we use our function machine. We plug -3 back into here and figure out what our y coordinate is. Well, when I plug -3 into here, I have 2 times -3 plus 6. That's -6 plus 6, which equals 0. So when I plug this x in, when x is equal to -3, I know that y is equal to 0. Again, now I'm just going to pick points that are smaller and bigger than my vertex to find ones on either side. So if I plug -4 into here, let's do that over here. 2 times -4 plus 6, that gives us -8 plus 6, which is -2, and the absolute value of -2 is +2. Now if I plug -5 into here, I have 2 times -5 plus 6, which is -10 plus 6, which is -4. The absolute value of -4 is +4. And then can you see a pattern here? I bet if I plug -6 in, let's see, 2 times -6 plus 6, absolute value, that's -12 plus 6, -6. Absolute value of -6 gives us a +6. And it's going to go on the other side just the same. And we can check that. You know, you could check that by putting 2 or 0 in here. 2 times 0 is 0, plus 6 is 6. So now we graph our vertex, and then graph each of our points. -4, 2, -5, 4, -6, 6. There we go. And we connect. All right, let's take a look at our domain and range. Well, our domain goes forever and ever in this direction and that direction, which gives us all real numbers. And the range, there's no point on my graph that goes this far down. So there's not a single point on my graph that has a y value less than 0. So y is greater than or equal to 0 on this one as well. All right, I will record a second video for the second half of these notes.